Today we're going to be covering chapter 4.2 and 2.4, which we already kind of did in the previous lecture. It's just more about concavity, which I'll define. So first we'll define concave up and concave down. Um, what I'm going to do actually, Hikey, is I'm going to doodle to keep y'all engaged because I know y'all do not want to be reading slideshows like this. I know it is boring. So first we'll define concave up and then we'll define concave down. Let f of x be a function of where f double prime x is the second derivative, okay, of f of x, okay? First, f of x is concave up wherever f double prime is greater than 0. Okay, fair enough. Similarly, f of x is concave down wherever f double prime x is less than 0. The easiest way to do this because of the intermediate value theorem is to find the points of inflection like we discussed in the previous lecture, right? And then you can plug numbers in between the intervals to determine where f double prime is greater than 0 or less than 0. Easy enough, right? So I'm going to have you guys work out this guy, and then I'll walk through my work in a bit. And of course, I'm assuming that if you are back, you have already done it. So first, f prime of x is equal to 2x. That's pretty straightforward. It's just a power rule. And the critical value is x equals 0. Similarly, f double prime x is equal to 2, which means you have no points of inflection because there are no x values to equal 0. And the function is concave up everywhere. Okay, vibes-wise, you know what a parabola looks like, right? If you graph it out, that's what it should do. And then you say, oh, yeah, that makes sense. There's a min here, okay. It's concave up everywhere. Cool. The interesting part is that this tells you what concave up and decreasing looks like. It looks like, oopsies, it looks like this. On the other hand, this tells you what concave up, sorry, I meant decreasing. On the other hand, this tells you what concave up and increasing looks like, right? Which looks like this. Concave up increasing, concave down, concave up decreasing, okay? I personally like to say concavity first and then tell you whether it's increasing or decreasing. Tell you why in a second. But basically that means like concave up increasing instead of increasing and concave up. You'll see why. Okay, so similarly, right? I'm gonna have you work out negative x squared. With like the mins, maxes, and all that stuff too, okay? All right. First you'll have f prime is negative 2x. Again, critical value is 0. Not always 0. Okay? Not always 0. Similarly, f double prime is negative 2. No points of inflection just for this specific case. Concave down everywhere because this is always negative. Okay? You graph that bad boy out. We already know what this function looks like. It's concave down everywhere. But again, that's fun because now we know what concave down increasing looks like and concave down decreasing looks like. That's why we say in that order. Okay? So for example, if I have like concave up increasing, concave down decreasing, concave down decreasing, concave down increasing, right? We draw little parabolas out here, right? And you say, oh, concave up, look at this, increasing, look at that, okay? Concave up increasing looks like, meow, right? And then, concave up decreasing. There's actually not a good way to make this smooth. Again, this you don't need to know why. This is just an intuition thing. There's no good way to make it smooth. Uh, so I personally, there's an asymptote, and I'm sure you guys can vibe check why too. So it's gonna go something like that, right? And then at here, it's gonna be concave down, so one of these guys, and decreasing, like that. You see? Concave up, decreasing, concave down, decreasing. That's also how you can have decreasing, decreasing, right? You can still have a critical value without a min-max, okay? And then finally, concave down increasing, just like that. And again, no nice way to make this smooth. You see what I mean, right? Because there's no zero. So we know that there's an asymptote here. Beautiful in it.
Okay, so what I'm gonna have you guys do now is I'm gonna have you work through this problem. Okay, so find the x and y intercepts of the function, the critical values, any min maxes, increasing and decreasing intervals, points of inflections, intervals of concavity, and the graph of f of x, f prime of x, and f double prime. The graph of f prime and f double prime don't have to be perfect, okay? And the graph of f of x should use data that you gathered from points 1 through 5, okay? So, hit pause and then come back. And I'm assuming if you are back, you have already worked it out, or reasonably you got stuck, okay? So work it out together and it's gonna be okay. So first we'll find the intercepts of f of x, okay? So f of x, actually we'll do this in purple, kind of differentiate it. F of x equals 0 gives 7/3 x cubed plus 14x squared minus 7x minus 42 equals 0. We can multiply everything by 3, which gives 7x cubed plus 3 times 14x squared. I'm not going to do it out later. Minus 3 times 7 minus 3 times 42 is equal to 0. Everything has a 7 in it, so we're going to divide everything by 7, factor a 7 out, however you want to say it. X cubed plus 3 times 2x squared minus, oops, that's supposed to have an X in it. Why didn't anyone tell me? So divide everything by 7. 3x minus 3 times 6 is equal to 0. Okay, yeah, that should be sufficient. And then I'm going to factor by grouping. I'm going to group this. I'll call this x squared, x plus 3, minus 3. Wait a minute, wait a minute. Oops, not x plus 3, I'm so sorry. X plus 6 minus 3, x plus 6 equals 0. This gives me x squared minus 3, x plus 6 equals 0. Your x intercepts are going to be at x equals positive negative square root of 3 and negative 6. If you don't know how I got that, work the problem out yourself, and if you're still having a hard time, please revisit your algebra. I'm going to assume from this point going forward that you know how algebra works. Okay? Okay. Now, as part of our maxes, right? We have, or our extremas in general, right? We have these values here, right? What I'm going to have us do is plug it right back into here, okay? And I will give you the y values right now. Feel free to use decimals for this. You can also just kind of eyeball it. Like you can leave it as like 7 da 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 squared plus 28 da 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 minus 7. That's fine too. I don't care that much. On exams, however, I do care and I will give you nice numbers that behave very nicely. Okay. Max is going to be -2 minus √5, comma, f of -2 minus √5, which is about 61. Okay. And your min is going to be -2 plus √5, comma, f of -2 plus √5, which is about equal to -43. Okay. This first part. Second part is your critical value and intervals of increasing, decreasing, min maxes, all that good stuff. So 2, we'll take the derivative. F prime of x is equal to 7x squared plus 28x minus 7, which can be written as 7x squared plus 4x minus 1. Yeah, yep, okay, yep. And then I'm going to use a quadratic formula because I don't know how to factor that using grouping. So f prime of x equals 0 implies 7x squared plus 4x minus 1 equals 0, x squared plus 4x minus 1 equals 0, x equals, and then we're going to quadratic formula on the side. You know, I'll do it in a different color. Let's do it in light purple. Negative b plus or minus the square root of b squared minus 4a is 1, and c is -1, so I'm going to turn that into a positive sign, all over 2a. A is 1. And that gives me -4 plus or minus the 2 square roots of 5, because this is square root of 20. Square root of 20 is 2√5, all over 2, which can be simplified. Please do not just cross this out. Do not just cross this out. Factor the 2 out, like this. So then you can cross it out of both. And that gives -2 plus or minus √5. Cool. -2 plus or minus √5. Cool. So that is our critical value. Oops. Okay. That is our critical value. And we'll do increasing and decreasing to get the mins and the maxes. Okay. Okay. -2 plus √5. √5 is going to be greater than 2. Right? Because 2 squared is 4. So -2 minus √5 is going to be like -4 point something, okay? -2 minus √5. And because √5 is bigger than 2, -2 plus √5 is going to be greater than 0. It's going to be positive. -2 plus √5, and then 0 somewhere around here. 0 is not a critical value, okay? I just put it there so we have like a point of reference, okay? It's actually a little bit high, but it's okay. Okay, and then I guess for this is also 0.3. So 2 and 3. Okay, we're going to pick a number less than -2 minus √5. I'm going to choose a really nice one. I'm going to choose -100. Okay, so f prime of -100 is going to be 7. -100 squared is positive. -40 minus 1. That's going to be a positive number. All right. Next, I'm going to choose a number in between. 0 is not a critical value, so you can actually just choose 0. I'm going to say f prime of 0. Oops. F prime of 0, which is going to be positive 0, 0, negative. So that's going to be negative. And then I'm going to do a very big positive number, and that's also going to be positive on this side. Okay? Which means you have a positive to negative, so that's a max, and negative to positive, that's a min. Not a global necessarily, and in fact, it's not a global because of the end behavior of this function. It goes all the way up and all the way down. Okay? We know that f prime is this, right? And we know that it is above the axis here, below the axis here, and above the axis here. It hits 0 here and here, right? So you can actually graph f prime as follows. As follows. Okay. -2 minus root 5, -2 plus root 5. Okay, ready? Above the axis. 0, below the axis, at the axis, above. Ready, ready, ready? I'm gonna hit a 0 here. I'm gonna hit a 0 here. I'm gonna go above the axis like that. Or here is under. So I'm gonna go under like that. And then it's above. So then you're gonna go like that. And because this is a parabola and it's symmetrical, you know that this is the vertex, which is at -2. Comma what? I personally don't care. Okay. Great, that's it. That's the graph of f prime of x. And then increasing, decreasing, points of inflection. Time to do the second derivative, which we shall do in blue. F double prime x. Actually, I'm going to want the derivative there as well. And that is going to equal 14x plus 28. Okay? All right. When f double prime equal to 0, you have 14x plus 28 is equal to 0. 14x is equal to -28. X is equal to -2. Okay? That's going to be your point of inflection. This function just happens to have 1. Okay? And now we'll talk concavity. Let's put -2 here, and like 0 is like around here, right? Okay, f double prime, pick a very negative number. I'm going to choose -100. F double prime of -100 is negative. I'm going to choose another number for concavity on the right-hand side. I'm going to choose 0. And f double prime of 0 is positive. Okay? As a matter of principle, you should be able to switch between graphing the function, the derivative, and the second derivative, okay? Given one of the other two. Okay, 14x plus 28, that's easy. Let's say 28 is here. We know that, right? 28 is here. So it's going to be 0, 28. It's going to have a slope of 14. At -2, you hit the x-axis because f double prime is equal to 0, right? Something like that. Actually, something like that. Ooh, schmancy. That's it. Okay, ready? Now we're gonna cobble it all together and graph the original function. Okay, ready? Now we know that our function is concave up at less than -2 and concave down at less than -2, concave up at greater than -2. So let us write that down. 0 like here, right? Let's put -2 like here, right? Which means you have concave up over here, up, not inclusive of -2, of course. And here is concave down. Okay, okay. Next on the docket is increasing and decreasing. Our function is increasing at -2 minus root 5 and -2 plus root 5. Okay, so we're going to put that in. And -2 plus root 5 is like here. And then everything in between is decreasing. Okay, so I'll write that as negative. There we go. Okay, now that we have all of this, right, we're going to begin our graphing process. Okay, so let's say that's our graph. Um, let's put in some values, right? Let's talk about intercepts. We know that we have an x-intercept based off of part 1 at positive negative root 3. Okay, so let's put root 3, negative root 3, which is a little bit more than, or a little bit more negative than -1. So let's put it like right here. Negative root 3. And let's put positive root 3 right here. Right. We also know that we have another 0 at -6. Let's put -6 in like over here. Right. So off the bat, we have our 3 x-intercepts. Okay. What I'll do is I'll graph it in like a dark pink so we can kind of see what's going on. So we know there's a 0 here, here, and here, right? Our y-intercept we know is at -42. I didn't have to do it out earlier because you can just look. Just look, right? So we're gonna put that guy at, oops, it's kind of chunky, -42. And we're gonna graph that in as well. Like that. Okay. Now, here's the hard part. We have to make sure all these guys can be mapped nicely into here. But that is okay. That is okay. So what we're going to do, we're going to go in and label in the same way we labeled these pieces. Okay. We know that we have 3 intervals. So it's going to be -2 minus root 5 and -2 plus root 5. Okay. So I'm going to put in a different shade of pink. Let's put -2 minus root 5 right here, right? And -2 plus root 5 right there. Okay. Oops. There we go. Right. And then for concavity, we know we have a concavity change at -2. So in the same way, we will have it right about here. Okay. Okay. So back to the graph. So we established the zeros. Let's put in our mins and maxes. Where's my graph? Yeah, here she is. Okay. Our max is going to be at -2 minus root 5 to about 61 and a half. Nope, 61, I'm so sorry. This is almost, but not quite 61. It's a little over 61 actually. Okay. And then our min is going to be a little bit under, like a little bit greater than 43, negative 43. And we'll put her right there. Okay. This is your max. And this is your min. Okay. So we have all the important points in. Let's talk concavity. Ready? So from negative infinity to negative 2 minus root 5, it is concave down, increasing. So it looks like that. Which checks out really, because it's gonna go kind of like that. It's gonna kind of connect like that. Right? Nice and smooth. Right? Okay. And then from negative 2 minus root 5 to negative 2, it is concave down, decreasing. Concave down, decreasing looks like this. Again, checks out. But it doesn't hit 0 yet, so we'll refrain from that. Okay? From negative 2 to 0, oh, sorry, negative 2 to negative 2 plus root 5, it is concave up, decreasing. Concave up, decreasing looks like that. So it's going to kind of peter out like that. Doesn't have to be perfect. I understand the graph's like kind of cramped. Like I said, you can always fudge things around if you have to. There we go. Okay. Concave down, decreasing. And then from the intervals, she still keeps going. Oopsies. Okay. And then concave up, decreasing. And then from negative 2 root 5 to infinity, it is concave up, increasing. Concave up, increasing looks like this. So then we can just kind of whee. That's it. That's how you do it. Cool. Again, this particular problem is tedious because I insisted on having like all the bells and whistles, right? But it is okay. Thanks for your attention.